I'm going to make each and every one of you a ReactJS developer within the next half an hour. ReactJS is a user interface library developed by Facebook in 2013 and open sourced. So let's firstly give a brief overview of history of ReactJS. When Facebook acquired Instagram, Instagram didn't have a website. So the Instagram engineers approached Facebook engineers and said, hey, we want to use this internal library you are using. And therefore they open sourced React in May 2013 at JSConf, and Instagram website was built in ReactJS. When it was first announced, it was met with high criticism and suspicion. For example, one of the leading JavaScript developers, Ben Almans, tweeted, Facebook rating established best practices. And if you look at the Reddit threads on that day, people were joking whether it was April Fool's Day, whether this was messy and whether anyone would use it instead of AngularJS. But over time, lots of companies realized that actually ReactJS is a very good library for developing user interfaces. Nowadays, Netflix, Airbnb, Flipboard, HipChat, Khan Academy, and we at SellerCrowd use ReactJS successfully. If you look at Google Trends, you'll see that ReactJS adoption has been increasing at a very rapid pace. You'll see that it has a hockey puck like a structure. However, of course, statistics always lie. So if we actually compare ReactJS to AngularJS, or AngularJS is the red one here, you'll see that it's still not that popular. But this should not dissuade you from using ReactJS, because if you actually look for people who search for Google on Google, you will see that it completely swamps the other searchers. So this should not be taken as the whole criterion. So what are the main difficulties in building user interfaces? And what's the main goal of React? On React website, they mentioned that the main goal of ReactJS is to build large applications with data that changes over time. And they want to do this in a simple and fast manner. And the emphasis is on data that changes over time. We'll turn back to that later on. So if we consider server-side interfaces, that is, if you build your HTML on the server side, it could be any website, like PHP, Django, Rails, we see that actual generation of HTML is pretty straightforward. You first go to your database, collect some data, and then pipe that to your template engine, and out comes an HTML, right? This is a very straightforward process. And we see that straight server-side interfaces are pretty easy to build. Actually, we could abstract this as a function that simply accepts some data and outputs some HTML. And effectively, we are freezing time when we do this application. That is, when we approach the database for data, and afterwards, we assume that the data doesn't change while our rendering phase. Now, let's first turn back to why client-side interface building is hard. So for a long time, people thought that the culprit was JavaScript, that JavaScript was to blame because it was not a very well-designed language. And it's somewhat true. Like, it was designed in 10 days by Brandon Ike in a hurry, and it has some weirdnesses, some corner cases. But actually, as Douglas Crockford has said in his phenomenal book, JavaScript, The Good Parts, JavaScript is very flexible, very powerful. It is actually a Lisp in C's clothing. It has functional parts, it has object-oriented parts, and even with projects like ECMAScript 6 or CoffeeScript, or with libraries like underscore, etc., the language is not to blame. So what is to blame then? When we consider client-side interfaces, time is to blame. So let's say our application starts. The user starts his browser, the application starts. At that point, our application is now alive. That is, the time is not fixed. So we start with an interface and data. The user interacts with the interface, and we get a new interface, and at the same time we get some new data. You'll see that if you are not careful, the interface and the data will start drifting apart. And as time goes on, as the user interacts even more, the state changes, we get a newer interface, we get a newer data. And we will see that the HTML we see, or the user interface we see, is no longer a function of the data we have. That is, it has become unsynchronized. We have lost the synchronization between the data and HTML. It's like they are playing a catch-up game, and we are trying to beat the other. So let's consider an example application, a chat application. So at the top, I have a number of people online, for example, 10 people online here, and at the bottom we have a people list. Now let's say that another friend of mine goes online. So what happens then? There's a single data change, right? Only a single person was appended. But there has to be two view changes. That is, the number 10 must be changed to 11 at the top. And also my friend's name and avatar, etc. has to be appended to the end of the list. Now if you are not using any framework like ReactJS, Angular, etc., if you are using only pure JavaScript or jQuery, we'll see that we have to do two different changes in view for just a single data change. Now this might be a simplistic example, but most of the problems in user interface building is because of this catch-up between data and view. Now React has a different approach, and this is the fundamental approach of React. It says we will simply re-render the view all the time. Now why are server-side development easy? Because we just refresh the page, right? We send it to trash, we get a completely blank new view that we know that's fresh. Like when you are in an application, if it doesn't work, what do you first do? You press the refresh button, right? The aim is to make it to a known state, stable state where you know it works. So React takes this approach and says, why can't we apply it on client side? That is, if data changes, just re-render the whole view as if the user has pressed F5 or whatever, refresh button, right? So we will re-render the view all the time. So if there's a new data, we will just get a brand new view. Now we have our data, we generate the interface. We have newer version of data. From the data, we generate a newer interface. See that there is no transition between the interfaces we do manually. We just look at the data, we say it should be rendered like this. And if there is newer data, it will simply re-render the whole interface. And we'll see that by doing this, now the HTML or whatever interface output we have is a function of data. Okay? So now you'll be wondering, wouldn't it be too slow, right? If we are rendering all the time, if we are sending whatever we have to trash bin and re-rendering everything, wouldn't it be slower? So for example, let's say 100 people in our online people list, and a friend comes online. We are going to generate a new list, 101 people, right? Now if we were to just discard the 100 people view and generate a 101 people view from scratch, it would be slow. But here, React has a genius technology called virtual DOM. So basically, instead of generating real DOM elements, it generates a virtual DOM data structure that basically holds your elements in memory, in a data structure. And when something changes, React makes a difference between the previous virtual DOM and the current virtual DOM. And through that, it detects what nodes have to be appended, what nodes have to be removed, and therefore it is fast. So, let's summarize the main principle. The programmer should be focusing on just the data structure behind the user interface and the changes in that data structure, and he should be defining how the data structure is going to be viewed just once. He should not be considering how the view is going to transition from A to B. Okay? Now the second rule of React, components. When we build user interfaces, if you talk to a designer, she will usually think of the user interface as some components. Now let's take an example of my Facebook page. We first see the whole HTML, but if you look closely, all these different colored areas can be considered different components. React's second rule tells us that we should be treating all these separate areas as React components. Or consider another example. Here I have a shopping list. You just dissect your application to different components. There could be multiple components within a given component. That is, there could be higher order components, but the basic idea is very easy. You just dissect it just like a non-technical person would do it, right? It's like building Lego blocks out of smaller Lego blocks and building your whole application from this composition of components. So let's take a look at a simple component. So we'll start with a hello world component. The syntax is very easy. So we have to pass an object to a React.create class. This object is called a spec. It's just a normal object literal with a render function. So every component has a render method. Okay? And in the render method, you basically return the contents of that component. So here we return a div with the text hello world in it. So it's very straightforward. Now this is JavaScript. This is not a new programming language, but you'll see that these div tags are actually not part of JavaScript. So you might be wondering where they come from. So this is actually called JSX. So this is a JavaScript extension that Facebook built. This is a very simple extension. It basically takes those div tags that you are accustomed to from HTML, but they are not HTML tags. It is actually sugar for a function call. So if you write div in angle brackets, it behind the scenes generates React.create element with div, null, and hello world. So this is completely optional. You don't have to use this JSX. You can just write your application in pure JavaScript. And you can write React.create element all you want. It's just a shorthand notation. But other than that, the beauty of React is it completely embraces JavaScript. That is, you can use any JavaScript construct you have, like if, for, you can use any library here. You can do whatever you want in this JavaScript language. This is not a DSL. This is just pure JavaScript we all love and hate. Now how are we going to display this simple component on the page? We simply mount it with a React render call. So on the left, we tell which component is to be mounted. We say a hello world component is to be mounted and where we are going to mount it. So it has to be an existing DOM element in the page. So in this case, it could be document.body, but it doesn't have to be the body element. It can be any existing HTML element you want. So it's as simple as that. So you create the component, you mount it, and your React application just boots up. Now let's go one step further. Let's create a compound component. A compound component simply uses other simple components as if they were native HTML elements like div, span, or image. So here I have a greeting component that uses two hello world components. Just a greeting component that says hello world twice. It's very straightforward. You just again create a React class with a render method, and here we see the beauty of React. We have just created a hello world component in the previous stage, and we can reuse it. We can reuse it to build a higher order component, a compound component. So again, we have to wrap them in a single root element, but other than that, there is nothing exceptional here. Now let's go one step further. If you have a question, yeah, you can interrupt me anytime you like. Now let's go one step further. So far we have created static components, like hello world saying both times. Now I want to reuse the same component, but in the first case I wanted to say hello Üstün, and in the second I wanted to say hello Özgür, right? I'm actually going to parameterize this simple component I have. So how is it going to happen? The parent, or the real name is the owner component, can pass properties to its child components. So it can pass name is Üstün, name is Özgür, name is Jose, etc. And those will be passed as an object to the child component, a normal JavaScript object. Name Üstün, name Özgür, etc. So these are called properties or props in React terminology. So whatever the parent passes to the child is a property. Okay? And you can access this property, abbreviated as props, in any method you want. That is, in your render method now, we see that instead of hello world, we say hello this.props.name. So this refers to the component here, props refers to the properties object it is getting from its parent, and name is referring to the name key in that properties object. Now you'll see that there are some curly braces here. So you don't write hello this.props.name, you write hello curly braces this.props.name. And again, this is a JSX extension. Behind the scenes, it's just sugar. So it just writes hello, comma, this.props.name. So it doesn't have to be a variable name here. It can be any JavaScript expression here. So think of these curly braces as your view into the JavaScript world. Like you can write 2 plus 3 or any JavaScript application you write. Or if you want a translator function, you can pass your name through that. You can do this.props.name.uppercase, and that name will be uppercase. Like you don't need fancy filters. It's just JavaScript. So you can use the uppercase method in your JavaScript application. Now, how is the parent component passing these props? It's very easy. It's just like you pass attributes in your HTML elements. Just like you define class equals foo, class equals bar in your HTML elements, you can pass these props as name equals Üstün, name equals Özgür to the child components. Now, at the beginning of the talk, I said that the real value of React is when the state changes over time, but so far I haven't given any example. So here we will have a counter component whose state changes over time. So it's a simple counter. It simply displays how many times I have clicked it, and it has an increment button. So if I increment it, it will say you clicked 4 times. Now remember that each component has an object called props. Each component also has an object called state, where it gathers its state variables. So props are variables that are passed from the parent. State is the object that you yourself manage. So how do you initialize your state? Again, just like the render method, there is a method called getInitialState. And in this getInitialState, you return a simple object so that this will become what your state will be. So here we are returning counter is 0. Just a normal, simple JavaScript object. And just like props, we can access this variable in this.state.count. So now we say you clicked this.state.count times, and it will simply refer to the state variable there. Now I'm putting the increment button. It's just a button. Now the real deal comes. I'm attaching an onClick handler to my button. Now this onClick handler refers to a method on my component. So I just say onClick this.increment, and I define an increment function in my object. Okay? Now what should we be writing in the increment function? We are going to increment the counter by 1, right? But we are not going to do it simply by incrementing as if it were a normal JavaScript number. Instead, we are going to use another React method called setState. So first, I pull the current value from the state object, I say current count is this.state.counter. And then I say status, the new value of status, counter is equal to the previous version of counter plus 1. Now, remember that I didn't simply say this.state.counter equals this.state.counter plus 1. Okay? This is the most important point in React. You have to do your state changes explicitly. Therefore, you have to make every state change through the setState call. That's the only thing you have to keep in mind. And through this, it knows that it has to re-render the thing. Otherwise, it would have no way of knowing if anything changed. For example, in Angular, there is no set state. You simply change the value. Therefore, in order to check whether something has changed, Angular has to run something called a digest loop, which is quite an expensive loop. If you don't use object observe, you use two values for each variable, and in that loop, you check whether each variable has changed. And while you're checking, those variables might change again. So you do it like 5 times, 6 times, whatever, until things settle down. And this makes Angular applications sometimes very slow and very hard to understand, very hard to reason about. In React, state changes are explicit with setState. So let's build upon this and modify this slightly. So we want the counter now to count forward as before, but we want it to also count backwards from 10. So it will say, you click 4 times, you have to click 6 times. We are trying to click 10 times in total. So if I click once, it will say you clicked 5 times, need to click 5 times. So with a single change, I want to make 2 view changes. Now, how many state variables do I need here? Just a single counter value is enough. Now, there are 2 view data, but there is just one real model data. Okay? And React forces you to focus on that. Like, what is the root data here? What is the derived data? Here, the derived data are these 2 numbers, but the real data is just a single number, the counter value. So React always forces you to think, what is my derived data? What is my root data? So it says, just store what is your root data in state, and just compute whatever is derived in your render method. Computing these these derived data is very fast in JavaScript, like if you are going to make a simple thing without external calls. So there's just a single change. For the state change, nothing changed. Like there's again this.state call as in the previous slide. Only my render methods changed. So it says you have to click 10 minus this.state.counter times more to me. Now see that I can use any JavaScript expression there. So I'm using a variable and I'm subtracting that from 10. Of course, this 10 could be variable, etc., but that's not the point. The point is that my application didn't have to change that much for a view change, because the data change wasn't there. Now finally, I'm going to talk about owner-child component communication. So far, the child might or might not maintain its own state, right? But what happens if the child wants to signal to the parent that the parent state should change? That is, child state will not be changing, the parent state should be changing. Now, React solves this via callbacks. Just like you can pass downwards normal numbers, in JavaScript, functions are values, right? So just like you can pass 5 downwards, you can pass a normal function downwards, right? So you simply pass your child the function to be called, and this is called the callback problem. So what happens here? Let's say we click the child, okay? The child says, whatever increment was passed through me, I want the parent to call that. Now the parent calls increment on its own and increments the number to 6. Remember, the parent has the state 6. Now it is passing it downwards as a prop. So the parent has the state, it is being passed downwards as a prop. And when it passes completely downwards, the number in the child will be now 6. So let's give an example for this. We have now 2 counters. Okay, now clicking one should increment one, but also decrement the other. Now where should we store state in this example? Should we be storing state in the child components, or should we be storing state in the parent component? But before we answer that, let's first look at the chat component first. So in the chat component, we have this 10 people online, and we have the person list component. Now, if another person comes into the view, where are we going to store the person list? Since the same data is used both in the number and both in the person list, we are going to store the data in the outermost layer, in the uppermost layer. And for that, for example, for the number component, we are simply going to pass the number of persons. For the person list component, we are simply going to pass the person names. So here again, the upper or the outermost component has 2 state variables, counter1, counter2. And it is passing these counter1 and counter2 as props to the child components. Okay? So if it's 0 and 5, it will be passing counter1, 0, and counter2, 5 as props. Now we'll see that our example will be simplified. So now our counters will no longer have state. We will return back to having them getting normal props. So again, it will say, you click me this.props.counter times, not this.state.counter times, okay? And you need to click me 10 minus this.props.counter times, and so on. Now the real complexity is shifted to the counters components. That is, in a way, it is centralized in the mother or in the parent component. So again, we have 2 state variables, counter1, counter2. We have 2 callback functions, increment counter1, which simply expects what you want to do. It increments the counter1, decrements the second counter. And we have an increment counter2 callback. It increments the second one, decrements the first one. And simply, we are passing these counter values to the counter child components. So we are passing both the counter value and the counter callback to the child components. Now the final example might have been a bit hard to understand, but if you want, we can return back in the question section. Now finally, I will briefly touch upon the other important topics in the React landscape. First of all, as mentioned in the previous talk, there has been a recent project called React Native, which has been announced but not open sourced yet. It is expected that it will be open sourced within the following month. And with this, you will be developing iPhone and Android applications natively with ReactJS. Also, ReactJS can be started server-side. So if you have a Node.js server, you can use this same components on your server side and send HTML to your users. There's also a Chrome extension called React Developer Tools, which is very helpful in developing applications. And also, when your application grows bigger, there is a Flux Library by Facebook that maintains state transitions slightly better than Facebook's React. So we saw that in React, you have to keep the state as high as possible, that is, at the outermost layer as possible. With Flux, you completely separate your components from state, and you store your state in data structures called stores, and your components simply subscribe to the changes in these states. So in conclusion, React has 3 rules. All state changes are explicit, applications have to be divided into components, and we have to always re-render data so that there is no synchronization problem. And React achieves this through the use of a data structure called virtual DOM, which it diffs instead of the real DOM. So you can find the slides and the transcript of this talk at this address. And if you have any questions, you're welcome to ask them. Thank you very much.
I see a very quick Q&A, like 2 or 3 questions.
Hi. I would like to ask you, what do you think is the main advantage, besides performance, of React against another engine like background?
Perfect. You are asking me to compare the performance of React?
No. What's the main advantage besides the performance that I think React is better?
Yeah, actually, most people fall in love with React due to performance, and that was the way it happened for me too. But the main thing is not the performance. I think it's that all these things are explicit. The state changes are explicit, but your passing as props is explicit. So it makes your applications very easy to develop and to reason about. For example, in Angular tries to reinvent everything. It has a DSL. It doesn't use JavaScript for building your HTML. It has a digest loop. JavaScript already has some loops, right? Event loop. It has its own digest loop. React, on the other hand, completely embraces JavaScript. So in your render method, you can use JavaScript. And I think the main battlefield is not JavaScript, right? And if you are going to win at this war, you have to use the most powerful language you can use, not a DSL, a real programming language. So React, that philosophy makes developing things very easy and fast.
Hi, how does React handle server-side changes or server-side pushing in order to update our components or so?
You mean sending data from AJAX calls from the server? Yeah, so that's one of the beauties of React. Like, it's completely agnostic about this. Like, wherever your data comes from, you just call set state, right? You get new items wherever you get them. AJAX calls, the user clicks something, etc., etc. WebSockets, it doesn't matter. You just call set state. So actually it's a view library, but at the same time it guides you towards thinking about your model. But at the same time, like for example, if you are using jQuery and AJAX call in your success handler, you simply call set state with your response value.
Let's see the other questions outside while drinking beer. Thank you very much.
Thank you.